Binary shifts are one of the fastest operations performed by a computer. Instead of using multiplication or division, the processor simply moves the binary bits. A left shift moves every bit to the left, increasing the value. A right shift moves every bit to the right, decreasing the value. Because shifting bits is so simple, CPUs use it to perform calculations much faster than standard arithmetic operations. Here are 2 ways a computer can multiply a number by 8. On the left, the traditional method performs 3 separate multiplications by 2. This takes more calculation steps. On the right, the processor simply shifts the binary number left 3 times. Each left shift doubles the value. 3 left shifts multiply the number by 8. This method is much faster, which is why modern CPUs use binary shifts whenever possible. Let's see how a binary shift works. Every bit moves one position at the same time. In a left shift, all bits move to the left, and a new 0 is added on the right. In a right shift, all bits move to the right, and a new 0 is added on the left. Remember, every bit moves together. The empty position is always filled with a 0. A left shift moves every bit one position to the left. After all the bits move, a 0 is added to the empty position on the right. In this example, the binary number 000101 becomes 001010. Notice that every bit moves together. No bits are left behind. This simple operation makes the number twice as large, which is why a left shift multiplies the value by 2. One left shift multiplies a binary number by 2. Before the shift, the binary number 000101 is equal to 5 in decimal. After shifting every bit one position to the left, a 0 is added on the right. The new binary number becomes 001010, which equals 10 in decimal. So the value changes from 5 to 10. Remember, every left shift doubles the value. That's why a left shift is the fastest way to multiply a binary number by 2. Now let's see what happens with multiple left shifts. We start with the binary number 000101, which is 5 in decimal. After the first left shift, the number becomes 001010. The decimal value changes from 5 to 10. After the second left shift, it becomes 010100. The decimal value changes from 10 to 20. Notice that each left shift doubles the value. So 2 left shifts multiply the original number by 4. This is why binary shifts are a fast and efficient way for computers to perform multiplication. Now, let's learn about the right shift. A right shift moves every bit one position to the right. After all the bits move, a new 0 is inserted on the left. In this example, the binary number 001010 becomes 000101. Notice that every bit moves together, and the empty space is filled with 0. Unlike a left shift, a right shift reduces the value. We'll see exactly how much in the next example. One right shift divides a binary number by 2. Before the shift, the binary number 001010 is equal to 10 in decimal. After shifting every bit one position to the right, a 0 is inserted on the left. The new binary number becomes 000101, which equals 5 in decimal. So the value changes from 10 to 5. Remember, every right shift halves the value. If you shift 2 times, the number is divided by 4. If you shift 3 times, it is divided by 8. Let's see what happens with multiple right shifts. We start with the binary number 010000, which is 16 in decimal. After the first right shift, the number becomes 001000. The decimal value changes from 16 to 8. After the second right shift, it becomes 000100. The decimal value changes from 8 to 4. Notice that each right shift divides the value by 2. So 2 right shifts divide the original number by 4. This is why computers use right shifts as a fast way to perform division by powers of 2. Let's compare left shifts and right shifts. A left shift moves every bit to the left. A 0 is added on the right. Each left shift multiplies the value by 2, so the number increases. A right shift moves every bit to the right. A 0 is added on the left. Each right shift divides the value by 2, so the number decreases. A simple way to remember this is left shift means multiply, right shift means divide. Now, let's practice what we've learned. Example 1. A left shift changes 6 into 12. The value is multiplied by 2. Example 2. A right shift changes 12 into 6. The value is divided by 2. Example 3. 2 left shifts change 3 into 6, and then 12. Each shift doubles the value. Example 4. 2 right shifts change 16 into 8, and then 4. Each shift halves the value. These examples show the simple rule. Left shift multiplies by 2. Right shift divides by 2. One important thing to remember is that bits can be lost. In this example, we are using an 8-bit binary number. When we perform a left shift, every bit moves one position to the left. The leftmost bit moves outside the 8-bit space, so it is discarded forever. A new 0 is then added on the right. Because one bit has been lost, the original value cannot always be recovered. This is called overflow. So when working with fixed-size binary numbers, always check if a bit moves outside the available space. Let's look at some common mistakes students make with binary shifts. Mistake 1. Moving only one bit. Remember, every bit must move together. Mistake 2. Forgetting to insert a 0 into the empty position. A left shift adds a 0 on the right. A right shift adds a 0 on the left. Mistake 3. Shifting in the wrong direction. Always remember, left shift multiplies, right shift divides. Mistake 4. Ignoring a lost bit after a left shift. If a bit moves outside the available space, it is lost, and this can cause overflow. By avoiding these mistakes, you'll solve binary shift questions correctly in your exams. Binary shifts are used in many areas of modern computing. They help CPUs perform arithmetic and process data quickly. Microcontrollers use binary shifts for fast calculations and efficient control. In computer games and graphics cards, shifts improve performance when rendering images and processing movement. They are also widely used in digital signal processing, robotics, embedded systems, operating systems, and data communication. Because shifting bits requires very little processing, it is much faster than normal multiplication and division. That's why binary shifts are at the heart of modern computer technology. Let's quickly review what we've learned about binary shifts. A left shift moves every bit to the left and multiplies the value by 2. A right shift moves every bit to the right and divides the value by 2. After every shift, a 0 is inserted into the empty position. Remember, if a bit moves outside the available space, it is lost, which can cause overflow. Binary shifts are simple, fast, and efficient. That's why they are used by processors to perform calculations much faster than normal multiplication and division.